Dilations and similarity. A dilation is a transformation that produces a figure that is the same shape but a different size than the original figure. The original figure and the dilated figure are similar figures. This is the symbol for similar. If two figures are similar, then corresponding angles are congruent and corresponding sides are proportional. Proportional means that each pair of corresponding sides are changing by the same scale factor. To find scale factor, you take the part of the new figure and divide it by the corresponding part of the original figure. So triangle ABC is similar to triangle A prime, B prime, C prime. So the original figure is ABC, and A prime, B prime, and C prime is the new figure. Whenever you see the prime symbols, that pretty much tells you that that's the new figure or the dilated figure. So we know that if they are similar, that all of the angles, the corresponding angles, are congruent. So angle A is congruent to angle A prime, angle B is congruent to angle B prime, and angle C is congruent to angle C prime. Now next we know if they're similar, then the sides are proportional. The corresponding sides are proportional. So side A prime B prime divided by side AB equals side B prime C prime divided by BC, and that also equals side A prime C prime divided by AC. So let's begin with our examples. So are the two polygons similar? If so, identify the scale factor and write the similarity statement. So we know that in order for them to be similar, first of all, the corresponding angles have to be congruent. So we see that angle C is congruent to F, B is congruent to E, and A is congruent to D. So the angles are congruent. So we can check that off. Now we have to check to see that the sides are proportional. So the easiest way to do that is to look at each side measure, and we're just going to number them numerically. So this is the smallest number, so that would be 1, this would be 2, and this would be 3. Now let's look over here. This would be 1, this would be 2, and this would be 3. Now we're going to prepare to set up our fractions. Okay, so we see here that we don't have any primes, so we can't easily see which one is the new figure and which one is the old figure. So we're just going to simply just assign one as the old and new. So I'm just going to say that this is my old figure and this is my new figure. So we know that to find a scale factor, we're simply going to put the part of the new figure over the part of the original figure. So for the number ones, the new figure is 1.5, and for the original figure is 3. For the twos, that'll be 3 over 6, and for the threes, that'll be 4 over 8. So what we need to do now is simplify each of these fractions and see if they end up to be the same number. So 1.5 divided by 3 would be 1/2, or 0.5. 3 divided by 6 would be 1/2, or 0.5. And then 4 divided by 8 would also be 1/2, or 0.5. So what we notice is that these three numbers are equal to each other. And what that tells us is that the sides are proportional. So if the angles are congruent and the sides are proportional, we can conclude that the polygons are similar. So we're going to write that they are similar. And we also have to identify the scale factor. So the scale factor is that common number that you came up with. So you can either write 1/2 or 0.5. I'm just going to write 1/2. And then lastly, we need to write a similarity statement. So just like a congruent statement, we're going to have our symbol in the middle, and we're going to have each triangle on either side, or each figure on either side. Okay, so I'm going to go ahead and name my first triangle. Again, I like to just count using my angle arc. So this is one angle arc, 2 angle arcs, and 3 angle arcs. So that'll be 1, 2, 3, or CBA. And I'm also going to look over here, 1, 2, 3, which is FED. So triangle CBA is similar to triangle FED. All right, let's take a look at example 2. So we're going to answer the same questions. Are the two polygons similar? If so, identify the scale factor and write a similarity statement. So we're told that PQRS and TUVW are rectangles. So what we know about rectangles is that all of the angles are 90-degree angles. So we can go ahead and make these marks within here. So with knowing that all of the angles are 90-degree angles, we can conclude that all the angles are congruent, right? So we've gotten the angles out of the way. So now we need to check to see that the sides are proportional. So we also know that with a rectangle that the opposite sides are congruent. So if this is 12, then this is 12. This is 4, then this is 4, 16, and 6. So when we go to set up our fractions, we really don't need to have 4 fractions to represent all 4 sides. We only need to do 2 because 2 of the sides are congruent. So I'm just going to focus on the 2 numbers that were actually written in for us already. So we would number this 1, this would be 2, this would be 1, and this would be 2. And I'll call this my original and my new. All right, so let me set up my 1s and 2s. So that would be 6 over 4 and 16 over 12. So when we divide 6 divided by 4, we end up getting 1.5. And then when we do 16 divided by 12, we get 1.3. So we automatically notice that we don't get the same number. And that tells us that the sides are not proportional. So because the sides are not proportional, that means that the figures are not similar. And since they're not similar, there is no scale factor and there is no similarity statement to write. All right, let's move on to example 3. All right, so we have to take a look and see if the polygons are similar. So let's first look at our angles. So I see that we have one angle marked as congruent and we have another angle marked as congruent. Well, that will automatically tell us that the other angles would have to be congruent as well. And that's simply because all of the angles in a triangle add to be 180. So our angles are congruent. Okay, so check that off. Now we have to focus on our sides. So let's number them numerically. So this will be 1, 2, 3. 1, 2, 3. And let's set up our fractions. And I'll make this my old and my new. So 1 would be 12 over 16. 2 would be 15 over 20. And 3 would be 18 over 24. All right, so when we do our division, we end up getting 0.75, 0.75, and 0.75. So that tells us that the sides are proportional. Okay, so if the angles are congruent and the sides are proportional, we can conclude that the figures are similar. And the scale factor is 0.75 or 3/4. Whether you do the fraction or the decimal, it doesn't matter. And lastly, we need to do our similarity statement. Okay, so again, I look at my angle arc. So this is 1, 2, 3, A, B, C. And for this triangle, we got 1, 2, 3, which is D, F, E. All right, and let's look at our last example, example 4. So this one is similar to the last one. We have two angles marked. Now, if these are both 90-degree angles or right angles, then that tells us that they are the same angle measure, which is congruent. And we know that automatically by default, these third angles are also congruent. So we see that our angles are congruent. All right, so let's go ahead and number our sides. 1, 2, 3. 1, 2, 3. Set up our fractions. So mix my old and my new. So that's 18 over 45, 24 over 60, and then 30 over 75. When we do our division, that gives us 0.4 here, 0.4 here, and 0.4 here. Because all of those numbers are the same, that tells us that the sides are proportional. So because the angles are congruent and the sides are proportional, the figures are similar. The scale factor is 0.4, and our similarity statement. So we got 1, 2, 3, LMJ, and then 1, 2, 3, PNS. Oh, that is not a P. PNS.